Hey everyone, welcome back to the channel. So around the middle of last year, I built this Martian III frame and named it Damon. And also did a build video of that, and if you want to see the original video, I'm gonna post it in the description below, or linked somewhere up there. But yeah, so it flies great, and I've been flying. Obviously, you can see that I've been flying with it for quite some time now. But since I did that build video, a lot of things has changed about Damon, and wanted to talk a little bit about that. So last year when I did the build video, there were a lot of considerations about what parts went into this quad, and I had to consider things like price and what parts were available to me at the time, and that determined which parts went into that build video. But ever since then, I've upgraded some parts broke, and I changed them with more reliable ones. So yeah, I'm really happy about how this thing flies. It's been through quite a few crashes, obviously, but yeah, it's still flying great, and I couldn't be even more happier about this squad. So right now we're going to do a redux of the Martian III build, of Damon's build, and with all of the upgrades that he's gone through so far, and how you'll get a quad that it's not the cheapest in the market. It does have some great parts, not the cheapest ones, but it's also not the most expensive quad you can build. So just follow along, and we'll build something like this. So let's start off with the frame. So this is when you get the Martian III frame, it comes disassembled, and we're going to have to assemble it yourself. It has this one has 4mm arms, and that's going to be very strong. It's very solid, and that's not going to break that easily, even when you crash. And it comes with I think this is the bottom plate, and this might be the top plate. We'll figure that out along the build. So it comes with a couple of plates, and the nice thing about this Martian III frame is it also comes with its own power distribution board. Now, it doesn't have any fancy things like a BAC, which will provide you with a 5 volt or 12 volt output, but at least it makes for a centralized platform where you can solder all your motor leads, and connect that to your ESC or something. This PDB also has all these screw holes because it's integral to the structure of the Martian III frame. And what I have here is this actually looks like the Predator, but this is actually a 4-in-1 20 amp ESC. It is made by Favorite Little Beast, or FVT. And for our motors, I had 4 of these lying around. These are Emax red bottom motors, RS225 2300 kV motors. And while there are better motors, I think there are better motors out there now. These still are very highly respected in the community. These are very good motors, and it's going to provide us lots of power and lots of speed for a quad. We are also going to be using these Dial Cyclone 5045 props. It's a nice color red, so it's going to go with a theme. This Martian III frame is going to have a red theme to it, and we'll customize more of our frame as we build, as you follow along during this build. Here's the Betaflight F3, and you wire your battery here, and then the ground goes here. This is the ground, and this is the battery positive. And as you can see, there are 4 terminals if you want to hook up your ESCs directly. Then you have some more pins for your buzzer. All right. So you have the RAM pin, similar to the Omnibus, and you have there the V out and then the V in. So this is where your VTX is gonna go, and this is where your camera is gonna go. Now I have this Runcam Eagle 2. So the Runcam Eagle 2 comes in both 4:3 or 16:9 format. So it really depends if you have if your goggle can support widescreen. And the nice thing about this is that it supports a wide voltage as well. It can go from 5 volts to 36 volts. And one of the key reasons why I got this Runcam Eagle 2 is also because that it has wide dynamic range, meaning that even though it's not exactly made for night vision like the Runcam Owl, it does provide good image quality even at low lights. You can also choose a variety of colors. You can get this in black or red or orange in this case. And the lens also, you can choose either a 2.1 or a 2.5 lens. Now, in this one, this is a 2.5 lens. The receiver that we're going to be using for this build is this FreeSky XSR receiver. Now, one of the main considerations I had when building the original Martian III build was that I was still using a Turnigy 9X transmitter with a DJT module, so I couldn't use any of these X series receivers. But now that I've moved up to a Taranis QX7, now I can use one of these XSR, or even you can even choose an RXSR, which is 1/3 of this size, but for a few more dollars more expensive. But for this build, we're just going to be using this XSR. Now the XSR features full 16 channels and has antenna diversity, and it's also a full range receiver, so you know, you get better range compared to the original Martian build. So I wanted to customize this Martian 3 frame a little bit, and in keeping up with the Martian theme, I'm gonna color this according to the color of the red planet Mars, with a little bit of poster color and a little paintbrush. And I am just going to quickly paint the sides of this frame. Awesome, check that out. It's not clean, but you know, it'll do. Next, we'll just apply some nail polish. Alright, now that we've finished painting our arms, it's a nice shade of red. Used 2 coats of poster paint and covered it with nail polish. And also our bottom plate is also a nice color of red, so that's gonna show up pretty nicely when we finish assembling our quad. Alright, so the way this is designed is that these arms go over the bottom plate like this. And then this is sort of a plate that's sandwiched, and again, it comes with a PDB, but it's not just a PDB board. It also acts as a reinforcing plate on top of these arms. We need to trim and strip the wires from our ESC, and we have to pre-tin our PDB pad as well as the ESC wires before we go ahead and solder that to our PDB. We then need to trim our motor wires to just the right size, and then put some heat shrink tubing over our wires, and then we are just gonna solder them together. Now here's a quick tip. You can use some twist ties or garden ties to secure your wires while you're soldering them in place, and this is just to temporarily hold them and make sure that they don't move whenever you're trying to solder them together. So we're just going to do that with all of our motors. Just trim, solder the wires, put some heat shrink, and then just rinse and repeat. Next, we'll take our flight controller where we'll pre-tin the battery pads where we'll be soldering our XT60 connector. And then we will take our red PDB, which will be where we'll be soldering our 4-in-1 ESC. And this red PDB is also going to make it more convenient for us to connect our other components and flight controller to. With this Betaflight F3 board, now we call this the positive and negative terminals that are supposed to go to your ESCs are now scattered all across the board, and I didn't have any an ideal port that I could use. Maybe I could use these two, positive and negative, and pad it to a corner, or maybe I could just so at least I still don't have to remove my 4-in-1 every time I removed my flight controller, or at least it's if it's shrouded here, I can just when I remove my flight controller, I could just flip it on the side. So that might be a solution. Another solution might be to just go directly to the ESC. So I'm still thinking about it, but let's try padding it, wiring it to these corner pads, so at least we'll have one positive and negative here, which connects to the positive and negative over there. All right. Another thing that you have to consider is what voltages are going to be used for your components that you're going to be wiring into this board. Now, if you can see, similar to the Omnibus F3, you have some. I'm not sure if that's going to be focusing well, but there you go. So similar to the Omnibus F3, you have a couple of pads here for for choosing which voltage you want for your RAM output, and the RAM output is the one that goes to your cam and VTX here. So right now it's pre-soldered to BAT. So if you take your multimeter here between the A GND, A ground, and RAM, you're gonna get whatever voltage your LiPo has. So if it's a 4S, it's gonna be around 16 something if it's fully charged. And if you are using a DSM receiver, you also need to make sure that this one is set to 3.3 volts, because that is the selector pads for these, which is where your receiver is going to. But in my case, I'm using an FR Sky XM Plus receiver, so I'm going to be soldering to the 5 volts so that I get 5 volts for my receiver, which I'm going to be soldering here. Then the right, so that's the bottom of the board, and then for my individual motor signal wires, I need to solder them to these motor signal wires, and then I can just solder one of the ground signal wires from the 4-in-1 ESC to any one of these grounds, since all of these grounds should be connected together. So we need to solder some 14 gauge wires to our ESC pads, and that's going to be connected to our PDB, which is going to be powering our 4-in-1 ESC. So here we make sure that everything's lined up and solder the positive and negative to the built-in PDB. Next, after making sure everything's tight, and we need to pre-tin our pads. All right. So again, the pin outs for the XSR receiver would be from top to bottom would be the ground, 5 volt. The yellow wire would be smart port. The green wire, that's the fourth wire, that would be for PPM, and the last white wire, that is for S-bus. So we're just going to be using this pin header, and we are going to be using all of these wires except for the green wire, because we're not going to be using PPM. Instead, we're going to be using S-bus. So we'll just put that away for a second. And also the yellow wire, which we'll be using for smart port. And we are just going to be twisting the 3 wires that we need so that they're nice and neat. Next is the signal wires from the camera and the VTX. Also, we're soldering their power lines to the RAM pins and the ground to their respective grounds. Alright, so the last thing that we're going to be wiring up is the signal wires, or the wire harness that connects the 4-in-1 ESC to the signal pads of the flight controller. And then we are going to be wiring the 4 signal wires to each respective signal pad on the flight controller board. Since we have our LiPo connected directly to the flight controller board, and it has a 5-volt regulator that's powering the flight controller board, we need to remove the 5-volt wire coming from the 4-in-1 ESC, because we don't need that anymore. Let's just connect this to our 4-in-1 ESC so that we can measure up the wires. So we have our black ground pin and the 4 other signal pins, and we need to route them up to each of their respective pads. So motor signal wire 1 is over to the right and 2 is over to the left, and we need to cut our wires to just enough to reach those pads. And then here we are soldering the ground and all of the signal wires to their respective pads. Here's my VTX, and it's I used just a little bit of double-sided tape, and I can just see enough of that LCD display, and the button over here I can just press if I just reach with my fingernails. So it's nice and secured. I zip tied it down as well with antennas, so just to give that extra security, so that's not going anywhere. And we are just going to need to plug everything in. Alright, so installing the Eagle 2 to your Martian 3 is pretty straightforward. So Damon came with these carbon fiber mounts, and which slots into these slots. And previously I had hot glued some piece of foam in between, and that became my mount for the first camera, the 600 TV line camera. And you can see it in the Martian 3 build video. But in this case, you can see that using the screws that came in with the Eagle 2, I was able to mount the Eagle 2 camera onto these carbon fiber mounts. Now, one drawback is that it only fits in this at this angle, so it doesn't fit the other screw holes. So we are stuck with this relatively mild or average angle for our FPV cam. But since I'm fairly new, I'm still quite a beginner. That's just going to be perfect for me, I think, while I hone my skills. And that's just gonna slot into the front, and you'll notice that the clearance between the posts are quite it's very tight. So here I used the washers that came with the Eagle 2. So there's a washer in between the screw, but for the front I just used the one of the shorter screws. So the Eagle 2 comes with different sized screws, so I used the shorter one here without the washer, and that's because I initially tried to use washers on all of these screws, but it wouldn't fit with these aluminum posts in the way, and I wasn't able to fit it in with the washer. But it fits pretty nicely with those screws without the washer. So yeah, and we are just going to attach our wires to the run cam, and then we'll close it up. Now we have that in. The the receiver secured, and we just need to plug this in as well. Sorry. Alright, there you go. Make sure the pin headers has the correct orientation. It's not going to go in anyway. If it's not, we probably need to put some double-sided tape at the bottom of this receiver too, just so that it doesn't move around. Alright, now that we've finished building our quad, we are now going to set up a new model on our transmitter. So just hit the menu key. Then I've already set up Damon on this transmitter because I've been using him for quite some time now. But we will be starting off fresh by clicking on this one and then hit create model. And then just press the page key to take us through its settings. So the first page is going to be the basic setup. And here we will give our quad a name. If you want to have capital letters, you just hold the enter key. And then just, you can give them the same name. You can give all of your models the same name. It's just going to, you just have to figure out which slot they're in. But yeah, if that's your thing, you can give all of your models the same name. If you want to set up a countdown timer, you can do this here, give that a name. You know, let's make it count down every minute. All right. So one thing I also like to do is to have my pre-flight checks turned on, because I want to, every time I switch to this model or every time I turn on my transmitter, I want to make sure that my throttle is in the lowest position, that all of my switches are in their default positions, so there are no surprises. Now you want to have your receiver connected as well, if you haven't bound it with your transmitter, this is where you will do so. If you have a different kind of receiver, like let's say if you have a D8 receiver, or if you have a long range transmitter receiver, then you can choose that as well. But we have an XM Plus, so we just choose D16. Oh, before you plug in your LiPo battery to your quad, make sure you're holding the FS button, and then you plug in your quad. Now once you have that, you just click on the bind button, and then it's going to bind, and then you can just unplug your LiPo battery and hit exit on this page, and you will be good to go. But I've already bound my receiver, so I'm not going to do that now. But basically that's how just how you do it. All right, so clicking on the page, we skip the heli setup and the flight modes. Now you see the inputs are already preset to AETR, so we're not going to touch that. Our mixers are also set up for AETR. Now for our channel 5 though, we will be giving that a name for ARM, let's say ARM. For our source, you click on that and just flick the switch that you want for that. In this case, it's switch A. Now we will go to the next switch, which is going to be maybe modes. Right, press exit, and then once again you just flick the switch that you want your mode switch to be on. In this case, I want it to be on switch D, then exit. Then lastly, we want to set up our beeper switch for the source. Again, just flick the switch. That's going to be switch B for me. But you can choose any switch you want if you want to. This is just my preference. So we go back out. And that should be good for now. We'll come back to this mixer page a little bit later. Now let's run Betaflight and connect our quad to our PC using a USB. Okay, we'll just go to the ports tab, make sure we have UART2 set for serial RX because that's where our receiver is connected, and then UART3 should have smart port, and click on save and reboot. Alright, so once it auto connects, or you know, in my case, I just don't like it to auto connect. I like to do it manually. Right, next we go to the configurations tab. Just make sure that everything's all fine and dandy. Here we can set the craft name. So I already put there Damon, and then we want to set our receiver to the correct type, which is a serial-based receiver. We also choose S-Bus because that's what we're using. And then make sure the telemetry switch is turned on because we are using telemetry and OSD, and just check all of those settings that they conform with whatever setting or flight controller you have. Next, we go to the power and battery tab where we want to set our minimums. So I just have these set to minimum cell voltage and everything. Now set your amperage meter to 232 if you have a Betaflight F3 board. Alright, next we are going to be setting up our telemetry. So for this you need to have your quad powered up with your LiPo battery, so you make sure that's plugged in, and also that your transmitter is already bound to your receiver. And that's because our transmitter needs to be communicating with our transmitter in order to be able to set up our sensors. So we'll just go ahead and click on Discover New Sensors, and that should be it. Just click on Stop Discovery. So if you will scroll up, you can see that there's different, all of these telemetry, all of these signals coming in from our receiver. It's giving us the current, it's giving us the voltage, but most importantly, it's also giving us the RSSI, which is short for the radio signal strength indicator. And that's it. Make sure that you have everything set up. So I've just set up the low alarm and critical RSSI alarms on the defaults, but if you want to change that, go ahead and do so. And lastly, we want to set up a display on our transmitter. So in case you're flying, let's say if you're flying LOS, you can set these up so that it shows your RSSI. So you just scroll through all of the different options until you see the option that you are looking for. For example, I want to display RSSI on this screen. I'll just go and look for that. Just the one without the minus or the plus. So the next time we go to our telemetry screen, you can see our battery voltage as well as our RSSI. We also want to make sure that our flight controller has this information as well, or at least the RSSI. So to do that, we just go back to the input tab, input page, and we set up a new input. We'll just name this something short, just to make it really quick. For our source, we want to change it to one of our sensors. Since we've already set that up, it should appear as one of the sources here. And you're just going to need to look for that RSSI source. Oh, there you go. So just select that. Now we need to go into our mixer tab, and with our empty channel 8, we need to give that a mixed name again. And for the source, we will just put in the input that we created on the input page. And for the weight, we want this to be 200 because we want our RSSI values to go from 0 to 100 instead of negative 100 to positive 100. So we will do that, and there you go. Now let's run Betaflight and connect our quad to our PC using a USB. And if you have auto connect turned on, then it should automatically take you to this screen. Make sure that your quad is not moving unnecessarily, and that it's lying flat on the ground, and that the RSSI value is showing up on this screen. Next, we'll go to the CLI tab, type in version, and this will show you the version on our flight controller. And then we want to set the small angle to 180. And this will allow us to arm our quadcopter even though it's not laying flat on the ground. And lastly, type in save just to make sure the settings are saved. Again, if you have auto connect turned on, then you will automatically be connected. If not, press the connect button. Okay, so the next thing we want to do is make sure that we have our battery disconnected, and go to motors tab, turn on that button, and then flick all the master slider all the way to the top before connecting your battery to the quad, and it'll emit several different beeps. And then you should bring it all the way down, and it'll bring out a separate set of beeps, a different set of beeps. So once we're good, just test each motor that it's spinning in the right way. Also, make sure that you had your props removed. Maybe just put on some tape on each of the motors just to make sure about the direction. Now going over to the receiver tab, make sure that our RSSI channel is set to aux4, because the first 4 channels are for the for your sticks. So channel 8 becomes aux4. And then we go to our modes tab, and we want our arm switch to be to arm when it's when aux1 is in the middle or the down position. So either of those, and that is because I also set air mode to aux1. which is channel 5, but only for the down position. So when I have my channel 5 or aux1 to middle, it'll be armed, and when it's down, it's armed and in air mode. Now we also set angle and horizon mode to aux2, and then aux3 would have beeper. Now lastly, we go to OSD tab, and then we just just put in any of the display items you want displayed. So here I have RSSI value, the main battery voltage, timer 2, current draw, the mAh drawn, and then I have my video format and goggles to NTSC metric, using metric, and then you just set your alarms to whatever value you want. And when you are happy with all of that, you just hit on the save button, and then you'll be good to go. Here are some pictures of the finished build, as well as the cost for the parts that went into it. So again, this quad isn't made from the cheapest of the cheap parts. It has good motors. It has one of the best FPV cameras out there, and it has a really great flight controller with all of the bells and whistles in it, and also good props. So this isn't going to be the cheapest build that you could make. But if you want me to make a cheaper one, you can also always check back on the original video, which it's just slightly cheaper, so maybe not. But yeah, if you want to go cheaper, you can swap out the motors for some cheaper motors like the Racer Star motors. Those are pretty good as well, but they're quite cheaper, much cheaper than this one. But of course, they would offer less performance. And you can also go the other way and go for more expensive parts. For example, there are a lot more better motors out there, more powerful motors. The FPV Cam is still top of the line, but this also has a Betaflight F3 board. There are F4 and F7 boards that are really great out there right now, and even the frame itself is quite dated. So those are the things you might want to consider if you're going to start building your own quad. What budget you want to build your quad at? So this is around $240–250 price range. So if you can go higher than that, you can go lower than that. It really depends on maybe your skill level. If you're just a beginner, maybe you can swap out for cheaper parts. But if you want to squeeze the performance out of your flights, then maybe you can go for the more expensive premium parts. Now this is going to be the last time I'm going to be discussing about Damon, because this year I'm working on a new quad. It's going to be a new frame, new parts, so it's going to be really great. So you do watch out for that. So yeah, so there you have it. So if you enjoyed this video, click on the like button. If you're not subscribed to my channel already, please click on subscribe as well, because we will be putting out new content, and lots of great stuff are coming in the next couple of weeks and couple of months. Right, so anyway, as always, keep building and keep flying.